Let's look at how the AWS DeepRacer vehicle makes decisions. Once you've trained a model using the AWS DeepRacer console, it can be loaded onto an AWS DeepRacer vehicle. This might seem a bit surprising, as so far in DeepRacer Student, you've probably only participated in the virtual league. However, in addition to racing virtually, you can upload your model onto a physical car to race on a real track. To do so, you can download your model from the DeepRacer Student Your Models section and load it onto an AWS DeepRacer vehicle. The onboard computer on the DeepRacer then uses this model to make decisions, a process known as machine learning inference. Machine learning inference involves running input data through a machine learning model, which then outputs a prediction. This prediction is based upon the past experience, or training, and subsequent knowledge, which the model has gained through this training. In the case of AWS DeepRacer, the machine learning model takes input in the form of images from the cameras and data from the optional LiDAR sensor. The model then provides output as to what it thinks is the most optimal steering and speed actions the vehicle should take to stay on the track. For example, a well-trained model would output that the car has to take a left turn for an image input captured at a left turn on the track, as this would maximize its chance of staying on the track and completing the lap. As you might imagine, the inference process can be quite compute intensive. In the case of AWS DeepRacer, the inference needs to occur in real time as the vehicle is driving on a track. We can measure the performance of inference with two metrics. The first being the inference rate, which is the number of inferences which can be done per second. And the second is the inference time, or inference latency, which is the time taken to run a single inference. Ultimately, we want to maximize the rate of inference and therefore the number of decisions made every second. But the rate of inference is dependent on many factors. The most obvious is the performance of the machine running the inference, such as the CPU, or central processing unit speed, whether any GPU, or graphical processing unit, acceleration is present, and the amount of system RAM, random access memory, which is available. There are also other factors. One is the machine learning framework used for training. There are many different frameworks available, such as TensorFlow, PyTorch, and Apache MXNet. These frameworks provide the tools and services to build machine learning models, including the training algorithms such as PPO and SAC, which you might be familiar with from the training algorithm chapter in this module. You don't need to worry about these frameworks, as it's all taken care of for you with AWS DeepRacer, but it is worthwhile at least having some awareness of their presence and purpose. So now that we have a better understanding of how the AWS DeepRacer makes decisions, in the next section we'll look at some of the challenges involved in making all of this work.